Try to think back to the last time you wrapped a birthday present. What did you do? And how did you do it? You probably laid the wrapping paper out, put the present on top, cut the paper to length, and pulled an edge of the paper up and over the box so it was fully covered. Then maybe you folded in the edges to create a nice line and pressed the corners into triangles or trapezoids, folded them in, and got to work with the Scotch tape. In each step, from lifting the box to cutting the paper to manipulating the paper to pressing and taping it, your hands knew exactly how much pressure to apply at each moment, when to pull the paper taut, when to let it relax, how to move it without creating a crease or a bunch up in the wrong place, and how to navigate around corners without tearing anything. You probably did it all without thinking much about it, but that doesn't mean it isn't an impressive feat. It's a delicate dance of force and finesse that feels effortless, but actually requires incredible coordination between your visual system, motor control, and tactile feedback. Now, imagine trying to teach a robot to do the same thing. Every step, every move, every subtle nuance of the procedure. Suddenly, what seemed simple becomes a nightmare of edge cases. Apply too much force, and the paper tears. Too little, and you get wrinkles. Move too fast, and the paper shifts out of position. The robot will need to seamlessly transition between different types of control, sometimes prioritizing precise positioning, other times focusing on force application, all while adapting to different materials and box sizes. This is a challenge that many automation companies have simply been avoiding. While robots have conquered many rigid manufacturing tasks, they've largely steered clear of delicate manipulation involving flexible or fragile materials. But avoiding these problems doesn't make them go away, and the potential benefits of solving them are significant. So that's what they're trying to do in today's paper. The authors have developed a robot that can successfully wrap rectangular objects using standard wrapping paper. It might not sound impressive at all, I know, but trust me, it really is. On today's episode of Journal Club, we're going to walk through how they did it. If you're already subscribed to our email newsletter, then you'll be getting this full episode in text, audio, and video form delivered right to your inbox in the next few hours. Journal Club, the latest academic research explained in plain English.